Continuing, we want to understand how f double prime helps and to an understanding of f. Okay, so the second derivative test. Suppose f double prime is continuous near C. Now, if f prime at C equals 0, that means C is a critical number, and f double prime is positive, then f has a local minimum. If f prime at C is 0, that is C is a critical number, and f double prime is less than 0, then f has a local maximum at C. Alright, this can be understood by looking at a picture. Say this picture. Here you can see you have a local maximum. F prime is 0. First derivative is 0, that is the slope is 0. And it is concave down. That is f double prime is negative. So that gave me a local max. Here is another example. F prime is 0. So slope is 0. You have a horizontal tangent. But you are concave up. That is f double prime is positive. Okay. First derivative 0. Second derivative greater than 0. That gave me local minimum. First derivative 0, second derivative less than 0 gives me a local max. Alright, so that is the second derivative test. First derivative 0, second derivative positive, that is this situation, local min. First derivative 0, second derivative negative, that is you have horizontal tangent and concave down. That gives me local max. Alright, here is an example. Let fx be this. Find its derivative. 4 comes down, 4x cubed. 3 comes down, 12x squared. Factor this. 4x squared, x minus 3. Second derivative, 3 comes down, 12x squared. 2 comes down, 24x. 12x is common. Okay, so you have these factors. To find critical numbers, first derivative is set to 0. Okay, set the first derivative to 0. You get x equals 0 from here, x equals 3 from here. Okay, 0 and 3. Second derivative test, you set f double prime to 0. F double prime to 0. You get 0 from here and 2 from here. Okay, 0. Now, evaluate second derivative at your critical numbers first. Okay, second derivative is 0, but second derivative at 3 is positive. So that means you have concave up. So that gives you a local minimum. Alright, but first derivative is 0, so we cannot conclude much. You need left, right. Oops. Okay, yeah. Now, second derivative is 0. You don't get much from the second derivative test. So you need to see to the left what's happening with the first derivative. What's happening to the right. So this means you're increasing first and then decreasing. You understand? So that gives me increasing then decreasing. That's a local max. All right. Here is a graph. Well, we will see more examples in detail, but I want to leave you with some example. This lecture slide will be available to you. More complicated examples. It's better if I solve some problem rather than read some problem to you. But if you do want to read, I will be leaving these lecture slides both in Dropbox and in Blackboard. Okay, these problems are getting a little more complicated and I would rather do them by hand, such problems by hand. Okay, until then, so this completes the lecture slides for section 3.3. I will of course solve some problems on web work now for you to see more.